Okay, as we look further down, I hope that helped, Nick, the information instruction you got. Because I look down the next piece on here, after we know we got 150 addresses, what if we wanted to put more addresses out there? It can be changed. You can actually change that. Let's say you wanted to put 60 addresses on your network. All you have to do is go into this section where it's maximum number is 50 and change that. But the maximum number total that you can have is 254 addresses. So this little router here can support 200, and let's say you put 254 PCs on it. We got 4 on it right now. But it'll support 254. It'll hand them out for you. So this 50 is just the default setting for it, that's all. Because most people usually, unless you're in a larger environment where you got more than 50 PCs, you wouldn't change it. At home, you're not going to have more than 50 devices on there. But in a building like this, you probably would. Mm-hmm. I've been in schools where they got, I've looked at sections where they got over 200 PCs in some areas.
So could all devices run simultaneously?
Exactly, but they're sharing the bandwidth. The amount of bandwidth.
Which could slow you down considerably. It could definitely, if they're all running at the same time and depending on what they're trying to get to and just how much bandwidth is sucking down. Like if you go to Google and you're looking at, say, YouTube, if you're looking at YouTube, that can suck up a lot of bandwidth depending on what the pixels are and all of that that's coming across the network at the time. If you notice, sometimes you can be in your office or you may be at the office and people say, "Oh, the network is running slow." Well, it could be at 1 or 2 levels. It could be at that lower, the lower level of what I call that OSI model, or it could be up at what they call the transportation level, which determines the size of the packet and all of that that's being pushed across the network.
Excellent.
Can we, because we keep going back to that model,
certain words,
can we go back to the OSI model?
I was going to say, can we list that?
Let's do that because we had got to application, presentation, and session, but we never really went through and finished. So it'll probably be good because we keep referring back to the primary aspects of it.
Okay.
So you could.
Well, I'm going to pull this down.
And
the reason for that, did you need it?
No, I'm okay.
Because I'm going to sit back here with Kenya for a minute.
Okay.
And this has information on it.
Okay. Again, that OSI model that I was talking about, you have. I'm gonna take it just a little different this time.
Okay.
I'm gonna start at the very bottom, which is your physical connection.
Now that's the layer we know.
That's the layer.
Yeah.
That's the layer that we deal with
The most.
That we deal with the most. And when I say we, people in networking, and for troubleshooters or whatever, you deal with the physical layer. And what is the physical layer? We talked about binary. We talked about the ones and zeros. Mm-hmm. The ones and zeros is that binary cable. I mean that Cat5 cable. I'm sorry, the Cat5 cable that you have plugged into the back of the router. Mm-hmm. You with me?
That's that physical layer. That you can use physical.
That's the physical layer. You can actually physically touch it or whatever. The physical layer. That's where all your ones and zeros go across the network. Mm-hmm. You have to have that. Then you have that next layer, which is the data link layer.
I'll read this definition on here. It says, defines the rules for accessing the physical layer, identifies devices on the network, checks for errors on received data.
And it does. That's at basically that's at a switch level, where you got it down. You're at the point where you got a switch, and there's 2 things on the switch that you're dealing with. You're dealing with the MAC layer and something that they call the ARP. Okay, and that the MAC layer is a unique address. Exactly. That's assigned to like a NIC card of some type or what have you, And then that ARP is an address table. It's a address table that the bridge or the switch will hold. And I mean, you can break that switch down to where it can be VLANs. It's amazing what you can do on that the switch level. But again, that's a totally different ballgame when you're talking about the switches, because they have smart switches.
Right.
Just like you got smartphones, you got smart switches. So again, that's level 2.
And that ARP that you mentioned, that's an acronym,
Address Resolution Protocol. And what that does is that gets all the addresses, and it knows every address that's on the network.
There you go.
That you got that's actually on the network. So you're doing, any address here that comes off of here with that MAC, and that goes back to years and years ago, probably in my time, when they had you had IBM and you had DEC and you had Xerox and you had everybody that wanted to do their own thing. Well, they came up with this OSI model, which made it convenient where everybody would be on the same page or whatever, no matter what happened, no matter what they did. So again, hence we came to this this OSI model, which does it for everybody. Any company brand or whatever that comes through there, they're going to use the data link layer. Everybody's going to do that. Be you IBM with SNA or Digital Equipment, Xerox, whoever. You got that data link level, and again, it interfaces basically with the switch. And again, you have all types of switches. You have the super sophisticated switches. There's so much you can do on this level. And then, of course, there's the other level, the next layer up, which is the network layer.
Let me read what it says real quick, because I know you're going to explain it. You got it upstairs, but I'll just read it.
Okay.
It says it adds information to the packet to determine how routers move a data packet from its source to a destination on a different network.
Okay. And again, that's basically what it does. You're at the network layer, and I say picture this like if you're coming through a train station or something, and you dropping something off. Well, each time you leave one place, you're getting there's something called encapsulation, which simply means that you're just putting a wrapper around. You put a wrapper around that physical layer that says everything is okay at that level. Then you move to the next layer. You put a little wrapper around that because it does some checking there and within the computer, and it says it's okay. Then it sends it up to the third level, which is networking. That's where you get your IP address from. It actually stamps the IP address on there. You have a source and a destination address. And that source and destination address, that means that the computer that you're talking to and the computer in which it's coming from. So you can, at this point, you want to go outside. If you're doing it inside your local area network, it'll all be handled on the data link layer. You won't have any problem because the switch will handle everything. But when you're getting ready to get up here and you want to go outside your network, when you're getting ready to go out to the WAN, that's basically when you're going to be using this network layer.
Later on I was going to show them something. I've forgotten the actual command, like I showed them IP config. There is a command that'll show you how the packet moves from one router to another.
Okay.
How it goes from router to router. You can see how you can see the path that it's taken
Right.
to get to it.
And I don't remember what it is, but yeah, it is one where you can actually see, because it goes through a number of routers to get to where you want to go to. And again, that's all handled here in this area here with that source and destination packet or whatever you have. And another thing too, this is what I've worked with mostly, these first 3 layers. And if at the physical link, that's where I would say 95% of the problems that you have with a computer or whatever is at that physical link layer. If something happens to your computer and you say, well, it's not on, it's not working, I can't see it. The first thing you want to do is to check to see that you got an idiot light, what I like to call an idiot light, on the back of your PC to make sure that it's flashing or it's doing something of that nature.
We had that yesterday.
Okay, that way you know too. Even if like we're working with them to put cables together, you'll know you can test your cable and your cable it might work fine on the tester cable, that when you go here and you plug it in and it's not working, it's something wrong. So you need to go back and check that cable. But again, that's the basic thing. And if it doesn't work down here, it's not going to work up here. But if you get up to this level here and you get to the switch, then you can say it's just easy for troubleshooting. Again, that's why the 7 layers for the troubleshooting. I find it anyway, so whether you like it or not. But then you go to the next one, which is the transport level.
I'll read it. It says it breaks data received from upper layers into data packets, checks incoming packets for errors, and reassembles them for the upper layers.
Okay, and what this does, it's a transport layer. And what it does, basically, it determines how much data is being pumped down through these packets or whatever, how much data is coming down that pipe. And then what it does some type of error correction and checking or whatever. This is where TCP, Transmission Control Protocol, actually works best. You have another thing here, UDP, that works here, which is a lower level. It doesn't do as much error correction and detection or what have you on this level, but it's here that's very, very important. And again, it's basically the size of the packet that's going down there. It kind of deals with that, just with the transportation of it.
Exactly.
So the next layer that we have going up
Sessions.
is the session.
Manages the connections between machines on the network, allows for multiple simultaneous connections between multiple computers.
Okay, and that there, you have to have a connection with another computer in order to talk to it. If you're going to talk to a computer, it has to have another one to talk to. If, for example, you're on Google, and I went from this starting with the top before, but we're going backwards now. But you'll see it goes around in a loop. Eventually, you'll see that. But what this does is this makes a connection at this level. It makes the connection to the other PC, so you'll know what you're talking about. You have to have a session layer in order to be able to talk to the computer, another computer, even if it's no more than, like if it's Google or Skype or what's another, Telnet, something that needs another part of the upper layer. You have to have a session connected to another computer in order to make it work. So that's actually 2 computers talking together. If you don't have the session, then you know it's not working.
They show TCP on the sessions layer, UDP, DNS, WINS. WINS is those.
Yeah,
under TCP.
probably NetBIOS.
NetBIOS, that's right, SAP.
So, right, all of that's under that. Then you would have the next layer, which is
Presentation.
the presentation level.
Enables different types of computers to communicate with each other by translating different data types into a common form.
Okay.
That's cool.
The presentation level. Again, this is nothing more than the way you're actually seeing something, the way it looks. Again, a picture, the JPEG. JPEG is if somebody sends you a file or whatever and you pull it up, it's at the layer where the operating system actually is looking at it. In your operating system, like Windows 7 or something like that, it actually has parameters in there that you can set it up. You set up and say, I want a JPEG file or whatever kind of file you want, or it's the way that something looks to it. It has to have a look. So again, if you think presentation, think of how something is being presented to you. And then last but not least.
But before you move on, this was a little thing that made me remember presentation. I gotta give this to everybody here. Somebody could be on a network in another part of the world using an Apple computer, which uses a different operating system than this computer here. But guess what? That layer will let you see what's going on with that Apple computer. That is, you'll be able, to read, or somebody send you email or whatever from an Apple PC without you having to do anything. That's taken care of. But if you had an Apple and you networked it in here to, a IBM computer, you'd have some work to do to get those two to communicate with each other.
And this is where, like, ASCII sits here at this level and stuff. you know, the different types of protocols too.
So application,
Yeah.
this at the
Application.
top, provides a set of tools that programs can use to access the network.
Okay, and here we go with application. Applications is simply Google, Chrome, Skype, something of that nature that you're looking at. The actual application is not like Word or what have you, but it's actually where you're sitting there and you got that computer up there, and then when you hit that enter button or whatever, you're interacting with the application. And you know that it's working. First of all, if you can, the first thing you know is, can I pull up Google? Okay, if you can't pull up Google, it could be a problem with the Google app.
That's right.
It could be, so you could have an app, when you're going through the troubleshooting aspect of it now, if you can't pull it up, it'll give you something that'll tell you, I can't display it for whatever reason. That could be a network issue, but if you can't pull it up for some other reason, there's some type of application issue there, so you may have to, maybe in the script or something that was written for it or whatever, it's been messed up, or maybe a virus got a hold to it, the browser was hijacked or something, you can't use it, so you can't pull up that application there. So at the very first thing, again, this is something real important for troubleshooting. So you know up here at the application level, if I can't get Google or Skype or whatever, then I've got a problem. So again, you went through the 7 layers. Now something that you might want to remember for the 7 layers, if you can't think of it or whatever, remember this, this is, what do you call them, mnemonics?
Mnemonic, yeah.
Okay,
Mnemonic.
you can do, please do not throw sausage pizza away. You've got the 7 layers, or there's another one that comes another way.
All people seem to need
data processing. So I mean, there's a couple of ways. I have always remembered this way. Please do not throw sausage pizza away, because I happen to like sausage and pepperoni pizza. So it was something that made it real easy for me to remember. But again, you can't have, when this is talking like this, it goes over here, and you have to have the same thing on the other side for the other computer.
That's right.
And what it does is it does a loop. And you have to have all of them acting in sync. You have to have your application layer, your presentation layer, the session layer, and again here, the session layer. They automatically connect, and then the transportation. Then you have the network layer, the data link, and then the physical layer. If any of these, if this is broke here, it's not going to talk over here.
That's right.
If this link is broke, it's not going to talk here. It's not going to talk anywhere. So when you boot the computer up initially or whatever, there's something that is called an IP stack.
Mm-hmm.
And if you pull that computer up, you can ping on something which is called a loopback address, and you might want to try that. You can ping loopback. Type in the command, if you can get to a command prompt, or if y'all can show him, or Robert, if you can show him how to get to a command prompt.
That window, just minimize it. And we're gonna go to command level, click start, and type in CMD. Right there, yeah.
You want to type in the CMD,
Right.
and then next to that you want to type ping loopback.
Oops, we didn't go into try that again. Should have went to a DOS window. Should have had DOS in a window.
Yes, it should.
CMD enter. There you go. Then you can ping.
It should come back with a 127.0.0 or either 127.0.0.1. One of those
Type
two.
in ping, PING.
Once you type in the PING.
Space. You got loopback? I never
Loopback.
did.
Ping
Okay.
loopback.
Right. L-O-O-P?
Mm-hmm.
I usually
It
type
should-
ping localhost. This does the
Oh,
same thing.
it does the same thing, yeah.
Wow.
But if you ping loopback,
Yep,
it should.
It did. It's got the.
And then you
forward
should get a TTL, which is, or something,
Mhm.
time to live.
slide. Yep.
Okay, and that tells you how fast that is actually going across the network, which it probably is in milliseconds or what have
Exactly.
you.
Yeah, milliseconds. And that's a good tool. What you just did is ping this computer.
Right, and that lets you know that the TCP/IP protocol stack is actually working. you don't have to worry about whether anything is wrong with your computer. Everything on your computer, this stack is working.
Exactly.
Because you were actually able to ping it, and once you ping, so if you're having a problem not getting out or whatever, then you know that that problem is going to be somewhere else.
Exactly.
If you're having a problem getting across the LAN or whatever, you know that you've got a problem is somewhere other than from the stack that you got from your basic PC to your wiring closet. You know everything is okay. But from your wiring closet, when you get ready to go out to the wide area network, that's where the problem could come in.
Exactly. So what I was trained to do is you ping your PC to make sure that stack is proper. If it comes back, you know that's good.
Right.
Then you go out, since you know you're getting out to the web, they got diagrams now, I'll show you, but then you ping your routers.
Right.
You ping your routers, the gateway.
Exactly.
And if it reports okay, now you know your computer and your router are good, then you try to ping an address
Right.
out in the world.
And as a matter of fact, ping the gateway. And the gateway would be 192.168.1.1, I believe.
Right. Ping.
Okay.
It's pinged in space.
Right. And if you ping that, then you know that that router is good. Now,
That's
hence-
basic troubleshooting. Oh, 192. Dot 168. Dot 1. Dot 1. Enter. And it should reply back to you. Boom, boom, boom.
So that means that it's talking, it's going all the way out to the network or whatever. So it's good. So now you should be able to pull up Google without any problem.
Problem.
There's a problem?
Yeah, we're not
connected to
You're not connected?
So if you ping
Oh.
Google,
Oh,
it
okay.
won't
It won't
it'll
reply.
fail.
Okay, that was okay, that's what I was getting ready to say. The next thing was, you can ping www.google.com. And you have to put the whole name in there. Now, when you're putting the name in there, you're using what we call the DNS, the domain name system or server. And what it's going to do is try to go out there and it's going to try to get an IP address. And that IP address, it will come back with a TTL.
If it does.
Time to live, if it gets out there, but it ain't
It-
going.
It's not.
If it not, then it's going to come back and say timeout or
Yeah.
no response,
Could not,
something.
Could not. Yeah.
Ping
No.
request, what does
Could
it
not
say,
find
cannot
host.
be fine, yeah.
Okay, so now you know where your problem is.
Exactly.
You know you don't have a problem with your TCP/IP stack. You don't have a problem with your switch or your router or whatever. So there's a problem with the WAN.
Exactly.
There's something wrong there.
So that's that call to your internet service provider.
And say that we're down on either you
You ain't paying your bill.
right. I didn't pay my bill. That's my bad. Checks in the mail.
Yep.
So
Believe me, I've seen it.
that's pretty